Today we are going to talk about beta oxidation of fatty acid. We only see the steps of beta oxidation of fatty acid and then energetics of beta oxidation of fatty acid. Now, first of all, fatty acid is converted to fatty acyl coenzyme A. In presence of enzyme, fatty acyl coenzyme A synthetase, which is also called thiokinase, and ATP is used here. As there is use of synthetase, there is use of ATP, which is converted to AMP. It means that there is use of two energy equivalents here. Now, this fatty acyl coenzyme A is transported from this cytoplasm to this mitochondria through mitochondrial membrane carnitine transporter. This transported fatty acyl coenzyme A is converted to alpha-beta unsaturated fatty acyl coenzyme A by an enzyme acyl coenzyme A dehydrogenase. Here is use of FAD, which is converted to FADH2, which gives 1.5 ATP through electron transport chain. Now this alpha-beta unsaturated fatty acid is converted to beta-hydroxy fatty acyl coenzyme A, and hydratase enzyme is used here. Water is added. This beta-hydroxy fatty acyl coenzyme A is now converted to beta-keto fatty acyl coenzyme A, and the enzyme used is beta-hydroxy fatty acyl coenzyme A dehydrogenase. Here NAD plus is used, and which is reduced to NADH and H plus, which gives 2.5 ATP through ETC. Now, this beta-keto fatty acyl coenzyme A is acted upon by thiolase to give fatty acyl coenzyme A and acetyl coenzyme A. Now, this fatty acyl coenzyme A further undergoes these 4 cycles, repeated 4 cycles, to form acetyl coenzyme A. Acetyl coenzyme A undergoes TCA cycle to give 10 ATP. Now, let us discuss energetics of beta oxidation of fatty acid. Normally, we study beta oxidation of palmitic acid. It requires 7 cycles. It needs 7 cycles of beta oxidation, which give rise to 8 molecules of acetyl coenzyme A. Every molecule of acetyl coenzyme A gives 10 molecules of ATP, so that total ATP from acetyl coenzyme A is 80 ATP. Now, as there is 7 cycle, there is formation of 7 FADH2, and 1 FADH2 gives 1.5 ATP, so that 7 FADH2 gives 10.5 ATP. And there is formation of 7 NADH. Single NADH gives 2.5 ATP, so that 7 NADH gives 17.5 ATP. And all total, gross total, there is formation of 108 ATP. But look here, there is use of ATP, which gives AMP. That is, there is use of two energy equivalents of two high energy bond, so that 2 ATP is reduced, that is decreased, so that net yield of ATP is 106 ATP. In this way, there is a release of 106 ATP from beta oxidation of palmitic acid. That's why beta oxidation of fatty acid is very important for energy production in the body, as it can yield large amount of energy.